And we are on. Good afternoon, everyone. And it's such a great pleasure to meet with you again. Of course, from me, your favorite uncle. Just waiting just a little bit for us to, before we get started. And I know most people are affected by, load shedding. But I just wanted for us to just have a little chat, a check-in session. Obviously, tomorrow is the big one. We are writing physical science. Okay. So just a couple of nuggets that I wanted us to share together. All right. Good afternoon, everyone. Good afternoon. It would be good for you to just send through your questions maybe now, and then so that I can be able to have a look at them, obviously, so that we can share some nuggets. All right. So I know by now you've been preparing, right? And I just want us to take a moment together to breathe, okay? Usa. I know you've been working hard, right? And at the end of the day, obviously, we can try to give it our best shot tomorrow. So I just wanted us to look at a couple of things that we can sort of discuss for tomorrow's paper. Number one, so the multiple choice section. Let's talk about that first. I have provided some material on multiple choice. Please have a look at them. And again, I still do say, if you find that multiple choice is really not your thing, I would recommend that you answer multiple choice as the last portion of your exam. Okay. So if you find that you've tried multiple choice and there are some sections that really give you a hard time, please look at the resources that I've already sent. I mean, I've done quite a lot of videos on multiple choice section, how to answer that, how to approach certain sections. There are some videos that I've done, especially on the revision section. So have a look at that. Okay. I want to say to all of you, please calm down. Okay. I know some of you are probably at a stage where you are just looking at tomorrow's exam, and you are filled with anxiety. Okay, this is not the time to be anxious. Okay, just make sure that from your side, you have prepared as much as you possibly could. Look at the videos that I have already published during the course of this week and even today. And I'm sorry that I had to leave it for the last minute, to publish those because I had to, there was a funeral that I had to attend in the past couple of days. So I do apologize for that. Just one advice. If I were in your shoes right now, and probably looking at tomorrow's exam and not feeling quite prepared, there are two things that I would do. All right, two sections that I would really make sure that I understood. Number one, I would say please make sure that you understand mechanics. Okay, so that would mean that your Newton's laws, okay, have a look at those. That's a very core section, because it helps you understand work, energy, and power. It helps you understand also a bit of momentum as well. Okay. And secondly, I would look at the electricity section. Remember, those are the biggest sections when it comes to, physical science. So having a look at that would kind of help you. All right. And please, if you're still feeling like you're not prepared, there's still a couple of hours for you to actually just consider, looking through the material that we've already looked at in the past couple of days, and also just the revision section. If you want to still go for the long format videos, you're more than welcome to do so. Okay. And by the way, that will also assist. Okay. Right. Now, something else that I just wanted to I've been getting some questions on the absorption spectrum. If you don't mind, I just want to just briefly explain that section, okay, so that you understand what is absorption, line emission, and line absorption. All right, so essentially when we talk about an emission spectrum, all right, I want to use something, a model that I can use. So if you think about light entering, right? So first of all, you've got light. In this case, remember, if when you take white light, it has a couple of, through an optically dense medium. So if you take, a prism, light enters there and it is split into different frequencies, right? If you remember Roy Biv, red, orange, yellow, blue, indigo, or green, blue, indigo, and violet, right? So in this case, it's split into those segments. Now, when you take that light and pass it through a gas, okay? So if you take light, pass it through a gas, that gas has got certain frequencies in it. And so what that gas would do is that it would absorb the frequencies that you would get from that particular light. So in this case, it would absorb. So as a result, there are some of the frequencies that wouldn't appear on the other side. So light entering a gas, and in this case, some of the frequencies absorbed. So that would be an absorption spectrum. Okay. Now, if you take a current, let me say just external energy, if you take current and you put it through a gas, right? In this case, what happens is that electrons get excited, okay? And once electrons are excited, in this case, once they get excited and they drop, in this case, from the excited phase into the steady state, in this case, the lowest phase, once they lose that energy, they then emit photons, right? And that is what we call the line emission spectrum. Okay, so in this case, just remember, once they talk about a gas that gets energy, so that would be an emission spectrum. Or once they talk about a hot gas, so it means that it's gases with energy in them. So in that case, that would be an emission spectrum. Really, there isn't much on that section. Most of you have been somewhat, struggling with that. Okay. Now, when it comes to the guidelines for the exam, make sure that you read, your instructions. I'm going to go through your questions in just a few. All right, just make sure that you understand your instructions. Normally, the most important one is that your answers must be to 2 decimal places. And remember, so what you do is, please, when you write your formulae, make sure that you write the formula in this case and then followed by the substitution before you change to subject of the formula. Okay, because what markers tend to do is that they would mark the correct use of the formula, the correct formula, right, as it appears on the formula sheet, right? So, and then secondly, what they do is then they would mark the substitution part. So they want to see that you've substituted correctly. So in order for you to maximize, the marks that you can get, please make it a point that when you write down the formula, it's as it appears on your formula sheet, and then in this case, then the substitution, and thereafter you can do subject of the formula and manipulate and do all your mathematical gymnastics. Okay, so I hope that kind of makes sense to you, and that you can apply that quite well. All right, and then so there will be one thing for sure, there will be a question on graphs. Okay, so you must always look out for that. So in this case, I want you to always be advised when it comes to questions on graphs and interpretation of graphs. Okay, please remember, there are 2 things to check every time in a graph. The first one, you always look for the gradient, what the gradient of the graph represents. Now, how do you calculate gradient? Remember, it's change in the y-axis divided by the change in the x-axis. So say, for instance, your y-axis represents, let's say, velocity, right? and your time axis, your x-axis represent time, what do? It's change in velocity, which is on your y, divided by change in time, which is on your x. Now, you might not know necessarily what that gives you, right? Now, what you do, you can take the SI units. So if you take meters per second and you divide by seconds in this case, so remember velocity is in meters per second, you divide by seconds, you'll realize that that gives you meters per second squared. So what is measured in meters per second squared? That would be acceleration, right? So in this case, what you do is that it means that acceleration in this case would be found by the gradient, in this case in a velocity time graph, something like that. So again, if you take a velocity, so a voltage versus current graph, all right, in electricity, when you take the gradient there, it's voltage divided by current, change in voltage divided by change in current. In this case, voltage is in volts, current is in amperes. But you'll see when you take your formula for V over I, you'll see that that gives you resistance, right? So in this case, it means that the gradient in a voltage versus current graph, that would be the resistance, okay? So remember, in a graph, there are two things to evaluate. I said the first one is the gradient of a graph. The second one would be the area underneath the graph. Now, how do you evaluate the area? You always take the y-axis multiplied by the x-axis. So it's rise multiplied by run in this case. So let's say for argument's sake, you've got meters per second, let's say change in y, in this case that's meters per second, and time. So if I say meters per second multiplied by time in seconds, meters per second times seconds would give me meters. So it means that if I take in a velocity time graph, I take the area underneath that graph, that would give me displacement, okay? So please remember, when you've got a graph question, you always will use, in this case, the two things, as I said, it would be the gradient underneath the graph, and it would be the area underneath that graph, okay? Right. And I think the last thing that I sort of want to emphasize now, remember, there is what we call scaffolding of questions, right? So what happens? They always start with a definition. Now, ladies and gents, I want to please advise you. The moment they give you, they say state a certain definition, okay? What will then follow after that, normally, is that the practice is they would ask a definition, and immediately after, the question after that would be an application of that particular definition. So what it means is that if you are looking at, they say state the principle of conservation of linear momentum, what does that mean? The next question probably might have to do with an application of momentum, okay? So please have a look at that as well, all right? Yeah, so as I was saying, scaffolding of questions. So they usually move from, definition, then an application type question, and then they move into a more advanced questions. Now, guys, there will always be questions that would kind of, put you at a dis-ease to some extent, okay? Please, I ask you, all right? Be careful of time, right? So when you find those big questions that might probably cause you to, you're not sure about it, I always use the 10-second rule. I'm sure you've heard me say this before. 10-second rule is that I will look at the question, all right? I will look at, read and then just highlight all the information that I need and just jot it down, into the diagram. But the most important thing is that if I spend more than 10 seconds and I don't have a cooking clue what to do next, all right, please pass, all right? because otherwise then you will end up spending unnecessary amounts of time, whereas you could be actually just collecting marks in the other stuff. Okay, right. For those of you who are crying about electricity, it means that you haven't watched my playlist on electric circuits. Please have a look at that, because what I've done is that I've made it in such a way that you can be able to watch it from the first video to the last. I keep building up as I go. Okay, yes, 10 seconds I did say. Okay, I know it might sound virtually impossible, but remember, guys, it's not something that's far-fetched. It's stuff that I have used myself, and I've found that it works, and it works incredibly. Okay, so that's the part that I just wanted to alert you off. Okay, so just one thing that I would like to say when it comes to those rather difficult questions, all right, it always will help you. Okay, so if it's work, energy, and power, and you write the formula and some substitution, remember, you will be able to collect marks that way. Physical science is made in such a way, the way that they've stacked it in the CAP syllabus is that they've made it in such a way that you're able to collect, just a few marks here and there, even if maybe you might not perhaps be clued up so much. You can be able to at least get to a level 2, okay, by simply writing down your definitions, and simply also being able to just identify the right formula to use. Okay, remember, you do get marks for that. Okay, so if it's that bad, okay, if it's really, really that bad, so you might just consider just looking at those definitions and making sure that you can do as much as possible in terms of your your equations, your formulae, as well as the substitution part of it. Okay, right. And yeah, I think that's just about it when it comes to what I wanted to say. There is one other thing that yes, here's what I wanted to say. So the thing about it, guys, is that please remember, I think you are going to get, first of all, intimidated by the diagrams. Why? Because it would be the first time that you see such a diagram. Okay, so I want you to think about it. So you haven't seen that paper before. Yes, you've seen other science, you've done past exam questions before, you've seen other exam papers, but you haven't seen that particular one that you'll be writing tomorrow. So please don't be intimidated by the diagram. So what you do is you go to your information, you highlight the most important parts, you interpret what it means. So for instance, if they say something is dropped, then we know, okay, so that's going to be, it means my initial velocity would be 0. If it was, from something that is, if you dropped it maybe from a building or whatever the case might be. So the interpretation of the language of science to the everyday language of what it actually means. Okay, so when I say it was moving and it stopped, so you know that the final velocity would be 0, right? So that's important for you to highlight. Okay, right. So as I did say, if you consider still multiple choice being a difficult section for you to look at, please consider answering that last. Okay, right. So what I want to do, ladies and gents, is I want to try and just look through your questions and see if there are things that we can have a look at, that we can perhaps maybe just clean upon. How do we use ratios in circuits? Oh yeah, I actually did such a question today. Now, I remember that particular question that you're asking about, so when they say that, let's say, the resistor 2, the ratio rather between resistor 2 and resistor 1 is 2 is to 1. Okay, I'm making an example. So remember, what you do is, it means that R2, you write it in there exactly like that. R2 divided by R1 is equal to 2 over 1. And you'll see that when you cross multiply, it almost becomes like it's reversed, okay? But in that case, just please consider. So when they say resistor 2 to resistor 1 is 4:1, okay? So you'll write it exactly like that. Resistor 2 divided by resistor 1 will be 4 divided by 1. And that would help you to kind of deal with those ratios, okay? Right. Hi, sir. So Simnigi Wendlovu says, hi, sir. What do we do when they give you a graph instead of values and ask for the work function in photoelectric effect? Okay, so remember when you want the work function, so think of your graph, nah? All right, so you'll see that your graph starts, let's say, somewhere there. So where your graph starts on the frequency axis, right? That is your threshold frequency, F0, right? So that means that you are going to take that F0 value, right? And you multiply it by Planck's constant, H, right? So that is how you get your work function, okay? So work function is Planck's constant, H multiplied by F0, the threshold frequency, and in that case, that is how you'd be able to get your work function. Okay, right. That was a very good question. The graphs, let's see, the graphs of electric circuits and getting internal resistance. All right, so to get internal resistance in that graph, you take the gradient underneath that graph, okay? So you'll take the gradient. So usually you'll find that it's a decreasing function. So what you do is you take the gradient and you'll see that it comes out as a negative answer, right? But please remember that the resistance is never negative, right? So you'll say therefore. Now, it depends. When your graph is voltage against time, voltage against current, in that case, the gradient would be the resistance. But when your graph is current on the y-axis against voltage on the x-axis, so it means that in that case, you need to get the gradient and take the inverse of the gradient to get the resistance. I hope that makes sense, right? So if it's voltage against current, then the gradient underneath that graph would give you the resistance. Of course, if it's for internal resistance, of course, it would come out negative, but you remember that you must make it positive, right? But if you've got current on the y-axis versus the voltage in the x-axis, then you get the gradient and you take the inverse of the gradient. Okay, right. I think that was a very good question as well. Will the cost of electricity be asked? No, that's not part of your syllabus at the moment. So no, please don't worry too much about that. In this case, sir, hi sir, that's Ramsey. Hi sir, when will we know when to use F is equals to KQ1 and E? So remember, F is force and E is electric field. So remember, when we talk force, that's F, right? When we talk electric field, then that's going to be the E value. Okay, so that's how you tell the difference. Okay, and Kagiso says, what's the relation between momentum and kinetic energy? I wish I could actually show you that. Now, think about it. If you think of momentum, it's M times V, right? And if you think of kinetic energy, all right, that's going to be half mv squared, right? So if you think about it, so it's half mv times v, right? So you can say, so half mv, that mv is momentum. So it means that if you want to get kinetic energy from momentum, you're going to say half of the first velocity, right, multiplied by momentum. So it's going to be a half of p times v. Half of p times v. That will give you the kinetic energy when you've got momentum. I hope that makes sense. You can actually write the formula down. Half mv squared is half mv times v, right? So mv is momentum, so in that case, that's going to be half of p times v. Okay, right. I hope what is fertilizers? No, please don't worry yourself about fertilizers. It's been trimmed out. That's going to be in paper 2. Tips for circuits, please. That's Mihlali. Mihlali, please, in this case, please just watch my playlist. That's the best tip that I can give you at this moment, okay? Right. What is Newton's law? Whoa. I'm not, guys, if you have to ask me this, yay, I'm not too sure, hey? Okay, right. How can you use Doppler effect to explain why we conclude that the universe is expanding? Okay, that's a very good question. Remember, so when we look at our line emission spectra, right? If you find that the frequency, let's say we take a gas, right? And that gas has got a line emission spectrum. So if you take the same gas from a distant star and you observe the line emission, and you see that it has shifted, in this case, more towards the longer wavelength, or in this case, lower frequencies, right? So if your spectrum has shifted towards the longer wavelength, right? In that case, what it says to you is that it is now, so that star is actually moving away from the planet, from planet Earth. So so that's why we conclude that the universe is expanding, because when we observe the line emission spectrum of gases from other planets, they seem to be shifting more and more towards the red side, or the red end of the spectrum, where we've got a longer wavelength and in that case lower frequencies. Okay, right. So I hope that makes sense. Let's see. Fertilizers, still some asking about fertilizers. Sir, the bouncing question, the initial velocity after the bounce is the same as the final velocity before the bounce? No. Okay, so it depends. If they tell you, or in this case, if we consider that kinetic energy is conserved, so meaning that the collision with the ground is elastic, then that would be the case. So it means that the velocity before would be the same as the velocity after the bounce, right? Or rather when it bounces. So, but usually in practice, you find that is not the case, okay? So in that case, what you would tend to do, the velocity before and the velocity after there would be a slight difference there. And in that case, that's because of the collision with the ground. You've lost some energy there, right? And by the way, that is what would help you also to calculate the impulse, okay, on impact with the ground, okay? Right, so that's a very good question again, all right? How to calculate angle of inclination on Newton's laws. Okay, so usually you would be able either to have the force between that angle. Okay, so let's say you've got a force there, and you would be somewhat able to calculate in this case. Or let me put it to you this way. If you are able to calculate the horizontal component, okay, of that particular force, right? If you can get the horizontal component, then what you can do, you remember that horizontal component would be the force, okay? So if you think about it, if it's acting at an angle and you're able to get that horizontal component, you know that it's F multiplied by the cos of that angle of elevation. So if you've got the horizontal component, you can be able to say it's going to be F multiplied by the cos, and in this case you would have F, and you've got the horizontal component, and therefore you can use your trig ratios to calculate that angle. Okay, I hope I'm making sense with that. I hope it does help. What is the difference between emission and absorption spectrum? I've tried to explain that. If you are not here when I explain that, please rewatch this video. Afterwards, I will be able to save it. Okay. Hello, Baba Nkosi. How would you calculate acceleration in electrostatics? That's a very good question. So in that case, I would imagine that they would have actually given you the mass of a particular object. So if you can calculate the net force, now we know how to calculate net force in electrostatics, right? So say maybe you've got 2-point charges, and in this case, depending on whether they are oppositely charged, or the charge is the same, you can calculate the net force, and then so use Newton's second law. F net is equals to ma, right? You would know the mass of whatever object, and you can be able to calculate the acceleration that way. Okay, right. And then says, how do you know when to multiply by 2? Okay, all the way to when to multiply by 2 for vertical and projectile motion. I'm not too sure. What do you mean by Oh, okay, I think you're talking about a time symmetry. Okay, listen. So when you've got a scenario where you are taking something that's going up and then going down, okay? So suppose that they asked you to calculate the total time of flight. Now this is the time from when it moves from one particular point, goes up, and then comes back to the very same point. Okay, now you can calculate the time, because remember, the time going up would be the same as the time coming down. Okay, so then what you do is you can just calculate the time going up, right? And once you get that time, all you need to do is just multiply that time by 2. I hope that makes sense. Okay, right. I think I've answered that well enough. I hope that makes sense. Sir, for the hot air balloon, what does the 5 seconds later mean? I'm not too sure what you are referring to, Lacey, but 5 seconds later, I really would not be certain what you are really answering what you're asking. For instance, if they say to you, calculate the time, let's say you're dropping something from the hot air balloon, right? And then they say to you, calculate the distance between the hot air balloon and whatever object you've dropped, okay, 5 seconds later. So in that case, it would mean you must calculate how far the balloon went during that 5 seconds, and you must also calculate the how far the object went during the same 5 seconds. And then what you'll do is you'll take the displacement of the balloon minus the displacement of the particular object, and in that case you will be able to get to that particular answer. I hope I'm scratching where it itches. If it's not, I'm sorry, perhaps you can try to rephrase that question. All right, guys, it's over 30 minutes. I was hoping it would be 30 minutes, but let's see if I can answer some more questions. If you still have some more, when do we take FG parallel as a non-conservative force? Hey, let me explain that, guys, because I've been getting that question a lot. Yeah, so remember, FG parallel is a conservative force. Why? Because it is a component of gravitational force. Remember, FG parallel essentially doesn't exist. What you are doing is you are taking gravity, right, and you are breaking it down into components. Okay, so essentially what it simply is that those components put together, they give you gravitational force. So FG parallel is is a conservative force. Okay, just as much as gravitational force is a conservative force. Okay, so the right-hand rule, please? Sure, I wish I could show that to you. But guys, here's how it simply, you apply it. Remember, so if you've got a generator, for instance, right? What you do is you're going to use your right hand, right? So in this case, this represents the direction of motion, your thumb, right? So let's say you've got magnets on this side and this side, right? So what you simply have, let me just use my calculator here. All right, so let's say here you've got a generator. Here's your armature that's rotating. Okay, so this rotation, I'm going to focus on this side, right? So this rotation, I'm going to show the direction of motion. So on this side, it's actually rotating upwards. So it means now on this side, my thumb would be pointed upwards. So this side, if it's going down, okay, if it's going down, then I say, well, my thumb would be pointed downwards, right? And then remember, your forefinger shows you the direction of the magnetic field, right? In this case, now think about it. So your magnetic field is pointed in that direction. And then your second finger, this one, the middle finger, all right, shows you the direction of your current. So say for argument's sake, you've got your, okay, I'm trying by all means to show it to you here. So you've got your armature that's rotating. So here's my thumb, it's pointed upwards. If it's a generator, remember, it's going to be my right-hand rule, right? So here's my thumb pointed that way. If my north side of the magnet is this side and my south side is this side, so then it means that my, my index finger would be pointed this direction. Okay, so what I do is I would check, okay, so I'm trying by all means to show you here, right? So if it's rotating like this, so I say, okay, so, hey, thank you for that, for those who are contributing money. And by the way, there are super stickers that you guys can use just to show thanks and appreciation. Thank you to those of you who are making contributions, however small, guys. It does make a difference. And thank you so much to the rest of you that have been doing that. Right. So what I'm just showing you there, so there it is. So my thumb pointed in the direction of rotation, my forefinger in the direction of the magnetic field, then I would kind of check where the current is going. Okay, so either they would say to me whether it's going from X to Y or Y to X. In that case, you use the right-hand rule. I hope that I've been able to explain that very well. Thank you so much. I see those of you who are contributing. And by the way, guys, there are also super stickers and super thanks. By the way, there's a super thanks feature where you can actually just contribute monetary, amounts, whatever you want to put that's in your heart. You can actually do that. Okay, you can do that during the course of this video as well. Okay, right. The function of slip rings and split ring commutators in electrodynamics. Remember what the function of slip ring is that they help us in this case with the electrical connectivity. So in this case, they help us with conducting electricity, okay? Or you can say with the movement, with the flow of current, okay? So that would be the function there. All right, sir, so babonke or bebonke says, how do you calculate the frequency in generators and motors when given the graph of voltage, current, and also in Doppler effect? Okay, now that's very important. That's very, very important. I remember the question that you might be referring to. They had given you time, and please, I want you to be very careful. In that graph, I remember when they had shown the graph. So remember, frequency would be 1 over period. So if they had given you time, for instance, right? So that would be the time. So you say 1 divided by that time. But now you need to be very careful. What is that time? It is the time to complete 1 full cycle. What is 1 full cycle? It's going up and going down. Now, the question that you might be referring to, you know what they had done? They had one going up and then going down, and they had another one going up again. So think of a sine wave, up and then down and then up again, and then in this case, so it would be a up, going the peak, and then you have a trough, and then you have another peak again, and then they had given you the period there. Now I want you to be careful. In that case, the period is not for one cycle, it's for 1.5 of a cycle, right? So in that case, what would you do, right? You would say 1.5, meaning 1.5 of a cycle divided by that period, and that would give you in this case the frequency. Thank you so much. I keep seeing those amounts. Thank you. I think it's written PBG irate. He says we love you. Thank you so much. Is it Kimberly Jim that's also making a contribution, or is it PBG? I'm not too sure. I see it going up there. Thank you so much to those that are contributing. And by the way, guys, I see someone else has just made a contribution as well financially. Thank you. I really appreciate that from the bottom of my heart. Okay, right, let's see if there are more questions that I can answer. So Newton's laws, I always get the signs wrong. How do you avoid those mistakes? That's a very good one, Kimberly. Please, guys, I want you to consider this. When you're doing Newton's laws, always choose the direction of motion as positive, right? Don't choose the direction of the applied force as positive. Okay, I see most people actually tend to make that mistake. Remember, you can still have an applied force that is acting against the motion. All right, so there was one question where something was going down an incline, but the applied force was actually in up the incline. So in that case, please consider this. You always you always choose the direction of motion as positive. Okay, so Kimberly, I hope that helps. Okay, so that all the forces that are opposing, right, the motion, then they are negative. And all the forces that are in the direction of motion, those would be positive. I hope that makes sense. Okay, all right, Dwayne says, sir, when do we use negative in electrostatics? Okay, so I don't know whether you are referring to the charge or you are referring to when you are calculating net force. I'm not too sure, Dwayne, you would need to be more specific, but let me just answer it generically, maybe for both scenarios. So you would be, let's say you are calculating the net force, right? So in that case, if you've got two forces that are in opposite directions, you must choose a positive direction, okay? So in that case, it means if the one force is acting in that direction and the other one is acting in the negative direction, well, in the opposite direction, then what you're going to do is you're always going to make sure that you consider the positive direction in this case, and the negative direction would be the other object that's going in the opposite direction. I hope I'm explaining that well. I know I'm babbling a lot right now, but what I'm basically just trying to say is choose a positive direction. It doesn't matter which one, right? At the end of the day, it would depend on that. Now, if you're referring to charges, please remember the only time, so when you're calculating force, do not substitute the sign of the charges. Okay, right. And thank you once again to the ones that are contributing. Avuyile, thank you so much. That really means a lot to me. Okay, right. So please consider in this case when you are when you are calculating for force, you do not substitute the sign of the charge. What the sign will help you is in knowing the direction of the force. So say maybe you've got two charges, P and Q, Here they are. The one is positive and the one is negative, right? So you want to know the force that's exerted on this one. So in that case, you know that they are attracting each other. So in that case, what does it mean? It means that this one would experience a force in that direction. So it helps you to know the direction of the force. So I hope that kind of makes sense. Okay, Abdullah, C3 Abdullah says, Nkosi, I did a paper and the W net was negative, but the object was still moving forward. Please explain. Okay, so I would say in that scenario, it is showing you that that object is actually decelerating. Yes, that would be it. So it means that object was actually decelerating. It means at the time when it was, let's say, I'm just making an example, say it was descending down, right? So it means the forces that are now dominating at that time are the forces that are opposing the motion. Okay, so that's for an object that is slowing down. I hope I'm explaining that well, Abdullah. That's exactly what would be happening in that scenario. Okay, M says, how do you know when to use sine and cos when doing Newton's laws? Oh gosh, I can you? Oh, right, M, or I'm not sure who that is. So please remember, so it means that you need to know your trig ratios, right? So in that case, when you've got a force that is acting at an angle, you need to resolve that force. Thank you, Babonke. Thank you so much again for the monetary gift. It really means a lot to me. So you would need to know that force. In this case, obviously they would have given you the force that's acting at an angle, and in that case you would also now resolve that force into horizontal component and vertical component, right? I would say to you, please just go and look at my playlist on Newton's laws. I think it's the second video where I'm doing forces that are acting at an angle, and you would be able to know when to use the horizontal and the vertical component. The next scenario would be when we are using something that's on an inclined plane, okay? PBG, again, you are contributing. Thank you again. He says, you are fine. Thank you so much. Thank you. Let's see. Jauge Lomaboya says, in Newton's laws with an inclined object, how do you know when to use sine and cos? Okay, I think I've just answered that. Sir, tell us any common mistakes to avoid in electric circuits. Right, that's a very good one. In electric circuits, just be careful. Remember, when you apply, Ohm's law, always be careful that you use voltage with its corresponding resistance. Okay, so when you're given a value for voltage, right, for the voltage of something, remember, voltage, you can't just use any voltage with any resistor, right? You use a voltage with the resistor that corresponds to that voltage. Okay, so for instance, let's say I give you the voltage across a battery, right? So in that case, what is that voltage? Which resistor is, corresponds to that voltage? So that would be external voltage. So it means now you must get all the resistors in your circuit. It means you must get the total resistance of your circuit and therefore use that external voltage with the external resistance. I hope that kind of makes sense. All right, let me see if there are more questions. How do I get level 7 in physical science? You watch my videos. That's the way to go. How do you draw vertical projectile motion graph, balloon and ball? Okay, I'm not sure when you say balloon and ball, whether do you mean the bouncing ball scenario? And if so, there's a question that I actually published today. Please have a look at it, where I showed you how to use the the bouncing ball, scenario. Please have a look at that. I hope that it might assist in you being able. So what I did there when I answered that question, I not only drew a velocity time graph at the end, but I also drew a position time graph so that I could be able to assist you to see how to do that. Please have a look at it, okay? They say, how do you calculate displacement area when given a velocity time graph in VPM? If an object was thrown upwards from a height that it reaches, then it reaches the ground. Okay, so I think you've answered yourself in a sense, because you get the area underneath the graph. Now, you need to note, if that area is a triangle, right? So remember, it's between the graph and the time axis. So if it forms a triangle, then you know the area of a triangle is half base times height, right? So you need to make sure that you get the base, right? And you take the difference between the 2 points and multiply it by the height, in this case, again, the difference between the 2 points. Okay, I hope that makes sense. All right, photoelectric effect, when is the gradient equal to the kinetic energy? Okay, I've never seen that per se, when the gradient is equal to the kinetic energy. In photoelectric effect, most of the time they give you a graph that has a frequency against kinetic energy. Yes, against kinetic energy. So the gradient underneath that graph would be Planck's constant. Okay, if you go and watch the video that I did on photoelectric effect, there's a second one that I actually published where I showed you how to do the graphs on photoelectric effect. You'll see that the gradient always gives you what do they call it? Planck's constant, H. Okay, right. All right, let's see. How can I explain the different objects? How can I explain how different objects with different masses have the same acceleration in vertical projectile motion? Okay, that is a very good question, Lucas. So remember that gravitational acceleration is only linked to two things, okay? It's linked to the mass of the planet as well as the radius, okay, of that particular planet. Now, I want you to think about it this way. If I was to prove that, so what do? I'll say weight is equals to, the force of gravity, isn't it? And now, what is the force of gravity? Well, of course, weight is equals to force of gravity. So weight is equals to mass times gravitational acceleration, right? And then, gravitational attraction force, it's equal to G, big G, which is the universal gravitational constant, the mass of the object multiplied by the mass of the planet divided by the radius of the planet squared, right? Now you'll see that the masses on both sides, the mass of the person on the, remember it's mg, and the mass of the person on the other side of the equation, remember it's m times the mass of the earth, so those would cancel out. So you'll be left with G is equals to big G, which is the, the gravitational, universal gravitational constant, multiplied by m, in this case, which is the mass of the earth, divided by the radius of that particular planet squared, right? So in that case, it is not dependent on the mass of the object, but rather on the mass of the planet and the radius. I hope I've answered that well enough. Okay, how do you draw vertical projectile motion? So that's J, vertical projectile motion versus time, graph, balloon and ball. Okay, so balloon and ball. I'm not too sure. I think you talking position against time, you did say. So for the balloon, usually they do say to us that the balloon is moving at a constant speed. Of course, we wouldn't be able to deal with any other scenario if they give us a balloon that's accelerating or whatever. Okay, so in that case, remember, so for you, what you would tend to do is draw a graph that is for the balloon, for position time graph, it would be a straight line graph. Whereas for the ball, let's say it was dropped from the balloon, you would see that the position time graph would actually be a parabola, but a sad parabola if you've taken up as positive, right? So it would tend to curve downwards, you know. So if you think about a position time graph, it kind of shows you, in a sense, in picture form, you know, it's almost like a space-time graph, right? It's showing you the picture of what is actually happening, right? The balloon is rising and the, you know, ball is kind of falling. And of course, if you take your ground as reference, then it would be going towards the ground. Okay, right. Swerve Forever says, how do you calculate coefficient of friction? That's a very good question. So remember that coefficient, a frictional force is equal to the coefficient of friction multiplied by the normal force. So to calculate coefficient of friction, you would need the value of the frictional force, but you would also need the value of the normal force. So in this case, your coefficient would be frictional force divided by your normal force. I hope that makes sense. What affects the current in photoelectric effect? Yeah, so that's a very, very good question. So what affects current in photoelectric effect? That's Kanye again. Remember, that would be the intensity of light. So it means, in this case, if you can increase the intensity of the light, in that case, remember, that would affect the current. Why? Because you now emit more you know, electrons per second. So increasing the intensity would actually increase the number of electrons per second that are emitted, right? And again, what would affect the current would be to increase or decrease the frequency, right? Now, of course, if you decrease it to below the threshold frequency, there's no longer going to be electrons that are emitted. But if you increase it, or if you increase it rather, in this case, then it means that you would now be able, your electrons would be moving much faster. In that case, the kinetic energy would be would increase. So as a result, it would mean that more electrons, you know, pass through per second. I hope that makes sense. So it means both an increase in intensity, increase or decrease, and as well as the frequency of the light that you are using. Okay, so Spepelo says, why does the coefficient of friction, why does it not have SI units? That's a very good question, because it is a ratio of forces. So if you think about it, I said coefficient is the frictional force divided by normal force. So think about it. It's force, which is in newtons, divided by normal force, which is in newtons. So newtons cancels newtons, and that's why it doesn't have SI units. Okay. Thank you, sir, for all that you have done. It is absolutely my pleasure. All right, so Dwayne again asks what is line spectrum. Dwayne, I've answered this question earlier on. Please, if you can, after this, you know, of course, I'm going to publish this video. You can just have a look at the first segment of this, you know, video, and you can actually get your answer. I'm trying to get to as many unique questions as possible. Explain, okay, basically. Okay, someone says basically it's moving away from the earth. I'm not sure what you are referring to. Hope says, when does the shape of velocity time graph form a quadrilateral? You have to calculate the area of the shape to get the displacement. Okay, so in this case, what I would advise you to do is break it down into normal shapes, right? So for instance, when it forms a trapezium, I don't like working with trapeziums. So what I would normally do is I would break it down into rectangle and a triangle. So rectangles and triangles, I can work with that. So that is how I would calculate the area. She says, okay. Zamumzi says, I quit. No, don't quit. No, this is not the time to quit. Okay, let's go for it. Give it your best shot. Okay, what happens when the intensity of the incident light is increased? I think I've just explained that. When you increase intensity, more electrons are emitted per second, right? So as a result, remember, it's not so much that the velocity increases or the speed of the electrons increases. In that case, what happens is that more electrons are emitted per second, and as a result, the current would increase. Right, Cassandra says, how do you calculate current in optical phenomena? Okay, so how you would calculate the current, that's a very good question. I think I saw that in one of the question papers. I think I did one such a question. So what you would do, guys, we've been it's over an hour now that I've been talking. So what you would do is you would calculate the charge, right? Sure, yeah. All right. So what you would need to do first is, depending on what you've been given, of course, there would be some indication. I remember in the question that you might be referring to, they had said to us, assume that something like one charge is emitted per something. I don't quite remember the question quite well. But what you would do is, obviously, you would need to find out what the charge is. Yeah, I think they also said something about time every second. So you'd need to calculate the amount of charge. Remember, current is equal to charge divided by time. It's the charge divided by the change in time. So if your time is seconds, then you'd need to calculate that charge, and then you'd divide by the number of seconds. Okay. Sir, please explain energy levels in photoelectric and also the spectrums. Okay, so the energy levels, I think what you're talking about. So please remember, guys, when they give you those energy levels, right? So what you do is you calculate the difference in the energy levels. Let's say you're given E1 and E2. So if you get the energy difference between E1 and E2, that is the energy that would be released by the photon. So if you take E1 minus E2, that gives you the energy that is released by the photon. Okay, so then you know that that difference in this case is equal to HF. Then you can calculate frequency and all other things that are related. I hope I'm answering your question well. Okay. Yeah, yeah, judging on the number of questions. Richard says, tomorrow, you'll be here until tomorrow, judging on the number of questions. I do agree. We've been here, guys, for quite a while. Yeah, and I think you can see from my eyes that I am quite exhausted. Yeah, let's see if there are any questions that would be still helpful. All right. All right. I think, guys, I've tried to answer to the best of my ability. Okay. I'm sorry if I wasn't able to answer all your questions. And once again, guys, I wanted to thank all of you who've been able to, just contribute any amount that you were able to. I really, really appreciate it from the bottom of my heart. And I really want to say tomorrow, for tomorrow, do the best that you can. All right. Try to, have an approach, have a strategy. I always say, having a strategy is much, much more efficient than just, trying to grasp. Knowledge is more impactful than, rather, strategy is more impactful than just knowledge. Okay. So yes, great. So you've summed up your theory, you know all that you need to do. But in this case, please just consolidate it with a strategy. What do I mean by strategy? When you go into the exam tomorrow, all right, know which question you're going to start with first, okay? Right, so you're already confident, let's say, on momentum. So start with question 4, right? Start with the momentum section, because you don't, obviously you don't get that wrong, so you know that you can score maximum marks. Because what happens is that, the moment you get a question correct, what it does is that it boosts your confidence. There's nothing wrong when you've got heebie-jeebies, okay, those butterflies in your stomach at the beginning of the exam. But remember, what will calm you down, what will ease you into the exam, is obviously as you continue, as you keep answering or getting questions correct, and seeing that the exam is exactly what you are used to. So I just want to leave it there, guys. And really, I want to say from the bottom of my heart, thank you so much. And by the way, we will be doing this on Sunday again, just in preparation for paper 2. I will be publishing some stuff on paper 2. Please always look out. And if you haven't hit the notification bell, please do that, so that you are alerted every time I'm posting something that is new. Guys, I want to leave it here, and I want to say thank you to all of you for joining in. I think this is the longest that I've been on a live session. And yeah, I want to wish you all of God's best. As you continue, we will be seeing each other again on Sunday. And please, for those of you who haven't considered subscribing, please stay on. And by the way, we're still going to celebrate 100,000 mark. And of course, I just wanted you guys to finish your exams, and I'll see how to celebrate that together with you. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.